Hello, everyone. My name is Brian Smith, and this is the third in a series of lectures that is aimed to prepare students for their first college level computer science class. So, I'd like to go over some of the things that we covered our last lecture, and then I'll be giving an overview of what we're going to be covering this lecture, and then we're going to get right into it. So, recall, if you will, some of the things that we were concerned with, that we were learning about our last session. So we started out talking about precedence and our order of operations. How basically there's always a rule for determining what happens first when we have a series of different actions that need to occur. And this kind of reemphasizes that one of those big thematic points in computer science is that as far as it is right now, our computers are deterministic machines. That means they do one thing after another. They follow a sequence, just like that idea of, if you're able to know the exact angle and velocity that a pool ball is traveling at, you'd be able to predict what happens next. So there's always a rule for determining what happens anytime we have a bunch of things we need to do, right? We also talked about some of those comparison operators. We talked about expressions, right? The idea that an expression can be evaluated down to a single value. But it doesn't necessarily have to be a numeric value. It doesn't necessarily have to be an arithmetic expression. We can have also, if you can remember, Boolean expressions. And the output of a whole Boolean expression is going to boil down to a single value. And Booleans can either be true or false. We learned about and, we learned about or, we learned about not, we learned about less than, greater than, less than or equal, greater than or equal to, and also the double equal sign, which is our equality operator. And all of these operators, they work just like our arithmetic operators, where there's some symbol and then two inputs on either side. Like 7 plus 5, we would have, 5 less than 7, or Boolean values, such as like true or false. There'd be some operator in the middle. And they do some work and they output some value. So just like a function. Then we talked about the definition of a function, conceptually, that a function takes in some number of inputs and produces an output. It does some transformation. And then from a math perspective, that a function describes a relationship between two different sets of values. And we did that thing where there was the domain and the codomain, and we drew connections between the input values and the output values. And remember, the big rule for our functions is that if we plug in the same input value or values, we should always get the same output. They're predictable. We can depend on them, and we can build off of them. That's what allows them to be one of the basic ways that we can have modularity and abstraction and make a big problem, break it into smaller, dependable pieces. So that was something that was critical to the definition of a function. So some number of inputs in JavaScript, we can actually have 0 inputs. There's always going to be an output. We talked a bit about data types, right? We talked about how we have numeric data types, then we have character data types. In JavaScript, the character data type is called a string. In JavaScript, the numeric data type is called a number. But remember that this is JavaScript. It makes things really easy for you, and it allows for a lot of ambiguity. So in other languages, we might have more distinct data types, like an integer, a float, a double, etc. So we talked about functions. We talked about the concept of a function. We also talked about this important distinction between defining a function and actually calling a function. And this is something a lot of people get mixed up on. I really highly suggest you go back and you practice making your own functions, defining your function, and then calling it with different inputs. See if you can do that. It could be something trivial, like add 1 to some input number, or something like that. I'm actually, at the beginning, we're going to do some review function definition. So if you feel kind of hazy on it, don't worry about it. I'm going to go over that. That's the first thing we're going to do this lecture. So yes, that idea that we have defining a function, which is saying I've got this function, a new function that's never existed before. It has this name. It takes these inputs, and these are the steps that occur. Right? It's like we're creating like a new entry in the dictionary. There's a new function. It takes these inputs. It does this stuff. And then on the other side, there's calling the function, which is actually inputting a real value into it and having it spit out a real output. Right? So one side, you're just saying, I've got a function. It takes some number of inputs, and we're going to call the first input, first name. And we're going to call the second input number of bananas they ate. And we're going to call the third input something like that. Notice, those aren't real values. They're like placeholders, right? And then later on, we will call the function. And we'll say, okay, for the first input, the first name was Joe. So we're going to actually plug in the string Joe. The number of bananas was 52 or something like that, right? Don't ask me why I use number of bananas for a lot of examples. I got bananas. I'm hungry, maybe. Maybe that's what's going on here. But we'll do an example of that. And then finally, one of the last things that we talked about before we stopped the last lecture was this idea of conditional statements. And conditional statements are this powerful mechanism a lot of programming languages have that allow us to execute some code only if something happens, right? This idea that if something is true, if we have some Boolean expression that evaluates to true, only then do you execute the code that's in the curly brackets. Go back and review that if you're not sure about that. We will do an example of that in here also. So if you feel like the last lecture didn't help you, I'll step through an example that'll actually combine both of those things. And of course, if the condition is true, execute these statements. We could also have else, which means if that condition was not true, if it's anything except true, do this other stuff. And you can think about like a fork in the road where if it's true, run this stuff. Else, run this stuff. And then if we want to create even more forks in the road, we could do if, and then any number of if else, and then finally an else for the catch-all for the last situations. Again, we'll go over that in our examples. So for today, what I'd like to do is do a bit of a review on functions because they're so important. I want you guys to have these down pat. I want you guys to really, really get this. And again, that idea, that other big theme that a lot of programming languages share some of these concepts, and sometimes the syntax, that's the particular way that we write these things, is not as important as the idea behind them. So when I go over functions, the things that we go over are pretty much going to be the same across different languages. They have a name, they have some place to describe the inputs, they have some way to describe the steps involved in them, and they have some way to spit out an output. So we're going to go over functions again. Then we're going to do a lot of examples today. I feel like that's probably the best thing. Then I want to talk about problem solving. And remember, this goes even beyond problem solving with regards to some specific math problem or computer science problem. This is kind of general, but kind of in the direction of using a computer to help solve problems. But again, everyone kind of has their own method. So take this stuff and add it to your method. Or if you don't have one down that's clear, feel free to take this one. But anyway, why don't we start? So I'm going to put this down. Oh, I had a bit of a different setup last time. Give me 1 second. I forgot something. Okay, so let's start off with a review about the syntax, well, the basic parts of defining a function, right? Let's do this. There we go. Okay. So in the 2 steps, this is the step where we don't actually do any action. We're not actually performing those steps. We're just saying, hey, I want to create a new function, and this is the name of it. These are the different parts of it. So I'm going to put things in brackets when it's a general case and I don't want to like actually create a specific example. So every time that we create a function, well, why don't we just keep it to JavaScript? So you'll use the keyword function. Then you'll have, here will be your function name. And again, you won't need those angle brackets there. That's just for the sake, just imagine you're plugging in a function name there, like count bananas or something like that, right? And then you have some parentheses. Now, I said something last lecture about anytime you see parentheses, you should be thinking about inputs. So in the case that we are defining a function, we have some curly brackets here, we're going to be putting in what are called parameters. So our first example, we're going to do something really basic, and we're just going to make a function that calculates your total amount of money owed if you plug in some amount of cost and also a tax rate. And the idea is pretty easy. So if we have a function, you start with a keyword function, you have your function name, and then you have your parameter names. Parameter name. And they're separated by commas. So if you have more than one of them, each one has a comma in it. So let's say this one has 2 parameters. Parameter name. Okay. Then inside here, we're going to have all of the steps that we're going to need to do, that our function is going to run through. Every time we actually use the function, our function is going to run through each of these steps. And then finally, somewhere in here, you're going to see the keyword return. Return is going to be your output. Remember the whole idea of a function? Take in some number of inputs, do some steps, do some transformation, produce an output, and you're going to return whatever expression is here. Whatever value, if you wanted this function, for example, if you wanted some useless function that always output the number 1, you could do something like that. Your function would run, and when it was done running, it would spit out the number 1. But that sounds pretty much a waste of having some inputs. It doesn't matter what we plug in, we're always going to output the number 1. But anyway, this is more like the concept of it. And so here, I'm going to do this again. Our output expression. How about I'll say that? Output expression. Whatever we want to be spit out at the end. So, the keyword function, that's actually, you type in that. Your function name, whatever your function name is. Each of your parameter names. Now this isn't our actual values, these are just placeholders, right? Then our steps. So here I'll say steps. All of the instructions you want to run. Maybe you create a variable, maybe you add some things and store it in a variable, maybe you do this, maybe you do that. And then the keyword return, and then our output expression. Okay, so why don't we do an example? see I was dinking around before that. Okay, so our goal here is to create a function that calculates the total cost plus tax. Okay, well, let's start out with the keyword function. And then the next thing, well, let's look over here. What was the next thing? Our next thing was a function name. Okay. So I don't know if you remember me saying this earlier, but what we call a function is very important. Because if we have 50, 60 different functions we're working with, it makes life easier if we can just look at the function name and know exactly what it does. So let's call this one cost with tax. You notice I do this thing where I capitalize the first letter of every new word, except for the first one. This little naming convention is called camel case, and it just helps us see the individual words. When we have a bunch of words combined, it helps us see those a little bit easier. Some people, they prefer to do this. It's honestly just a preference thing. But as long as we have some way, these are little tricks that help us to just see things and save time, understand them faster. But I really like camel case because I feel like it's a little bit less typing. Cost with tax. Okay, so now we have the keyword function. We have the function name, which we came up with, right? Then we have some parentheses. What goes in parentheses? Inputs. Always inputs. In this case, we're defining the function. So I'm not going to put in the number 45 for my cost and then 0.75 for the tax, because we want our functions to be able to take in different inputs, right? We want our functions to be able to handle calculating many different costs with taxes from different places. Functions are meant to be reusable. So we're going to have a placeholder, the name of the parameter. We'll call this first one, how about we call it cost without tax. Now that's a lot of typing, but I just want to be absolutely clear about this. And then also, we'll have tax rate. Okay. Next, we need the curly brackets to kind of give the boundaries of our function does everything from here to here, right? All of the steps that our function has are going to be between these two curly brackets. And we might include some crazy things like some if, some conditionals, or we might have, some other things. But this gives us an idea of where does the function begin and where does it end. Okay, now, well, let's see here. How about we make this kind of brain dead to really illustrate how much we can do within the function. So, should be able to figure out a formula for calculating the cost with tax. But why don't we do this? Why don't we first separately calculate the tax, then add the cost to the tax and return that? So remember, the keyword let allows us to create a little variable, a local variable. So this variable will allow us to store some piece of information. In this case, we want to store the tax. How much was the tax for this particular purchase? So let's do this. Let's call this one this tax. That's kind of weird, but just to remember that. How about we'll call it this tax cost? No, that's confusing. We'll call it this tax. So our tax will be our tax rate times our cost without tax. So for example, if I spent $100 and my tax rate was 10%, then I would multiply 100 by 0.10. Little refresher here. I'm going to do a little comment. 10% is 0.10. So if you want to convert, we're not going to use the percent means something different, by the way, in JavaScript. So if you want 10%, 0.10. You want 75%, it's going to be 0.75. Okay, now we don't know what the tax rate is because we might plug in all kinds of different things here in this second slot, in this second input here. So what we're going to do, and because our function can calculate any cost with tax, we're going to do this. cost without tax times tax rate. Now, on this step, we stored how much tax this purchase costed. Now remember, the whole point is to calculate the cost with the tax included. So ultimately, what we want this function to output is the cost and the tax added together. So we're already at that point, only 2 lines in. We've only done this line and another line, where we can actually have our return. Remember, return means output. And when your function is running, when it gets to a line that says return, it totally stops running and it spits out whatever is here, whatever this stuff to the right of the return keyword is. That's something that some people forget. They think, it might output a value and keep going. As soon as it sees that return, it spits out whatever value's here. Maybe, again, remember our useless function. Maybe it spits out the number 1 every single time, even though it calculated this other thing. And it wouldn't do anything below here. It would just kick out. It would kick out of this function and go to wherever it was before. But in this case, we're going to output the cost without tax, plus this tax. And that should do it. We created this little tool that allows us to plug in a cost, a tax rate, and it should output the cost with the tax included. So let's try it out. So if I wanted to, we defined this function, right? We created this function. Now we have this new function called cost without tax, cost with tax, that we can use anywhere we want, right? We could reuse it. We could use it multiple times. How would I actually use it? Well, in order to call a function, we're going to type the name of the function, cost with tax, and have some parentheses. Again, parentheses, input. Now, in the case that we're calling the function, we don't use these placeholder words called parameters. We actually plug in some real values. So let's do a really basic example to make sure that our function is working correctly. And this is something that's really important. This is called desk checking. Well, you can desk check without actually running your program. But we should always try to break our code. We should always think, what's the craziest thing someone could plug into our functions that would break it? And make sure that it's watertight. Make sure that it is foolproof. That way we can always depend on it, right? So this is super, super important. This is this is just good form. This is just a really, really good habit to have. It'll save you so much hardship down the road. If you get into this habit, every time you make some code, test it, try to break it, right? And there's actually a job called quality assurance, where one team in a company will create some code, and then this other group, the quality assurance people, will try to break it. They'll plug all kinds of different things into it in the hopes that they could break it. And when they find something that's wrong with it, they report it back to the first team. The first team makes some adjustments, etc. So there's a whole world of how do we break our code. It's very interesting. Okay, so like I said, we're not going to be plugging in placeholders. We're going to plug in some real values. Let's do some values that are easy to calculate. Like I did before, we did 10. Now, $100 is our cost without tax. And our tax rate is, let's say 10%, right? Now we should, just going through this, 10% of 100 is 10. So the whole thing combined should be $110, right? Well, let's try it. Nothing happened. Nothing happened, huh? Well, remember that if we want to display our results, we're going to need some kind of function, and we're also going to need to look in the console, right? So we did have the computer do that. The computer did actually run this function, did call the function, but we didn't display it in a way that we could see it. So let's pop open the console. Now remember, there's a couple ways to do this. The easiest one is right click, click inspect. Another one is F12. Ooh, I don't have, where's my F12? There it is. Okay. So I'm going to add another line here where I want it to actually output whatever this function call did. So I'm going to do console.log. And just a little reminder here, I'll get rid of this for a second. Let's do something like this, console.log 55. We're going to run it. So there it is right there, 55. Now what we want to do is we want to see the result of our function call. So cost with tax. Now we're going to plug in some real values for our cost without tax and our tax rate. So 100 and 0.10. If we run it, there it is, 110. So just kind of a refresher, really want to illustrate this point. What's going on when we get to this line here, cost with tax? Well, your computer is going to go look for something defined that's called cost with tax. Remember, when your computer sees some text that it doesn't recognize, it first thinks, is this a variable or a function that the programmer made? So it's going to go look like, oh, did the programmer make a variable called cost with tax, or did they define a function? Oh, yes, they did. So as soon as it sees this thing, it goes to look that up. It sees this entry in the definition. So it sees this definition. Then it's like, okay, well, I see that there's some parentheses, and I see that we actually plugged in some input values, some arguments. So it's going to take this 100 and replace cost without tax with 100. The reason that it did that is because this is the first slot, right? This is the first argument. So it's going to replace anywhere in this function where you see cost without tax, it'll replace it with 100. It'll be just a straight substitution. And our 0.10 is going to replace tax rate. So anywhere inside here, it's going to replace that with tax rate. So it called the function, replace this with this, replace 0.10 with tax rate, or tax rate with 0.10, and then it's going to run through the steps of the function until it sees the return keyword. It'll do let this tax equals. That means we're going to create a variable. We're going to create a local variable, and it's storing the result of this multiplication. In this case, this time that we do it, it's multiplying 100 times 0.10. Then it's going to return cost without tax, that was the original 100, right? Plus this tax, which is our local variable that we created. All right, so that's what's going on. It substitutes it. It looks for the definition of the function first, then substitutes in the values, then runs through the steps until it sees that return keyword. Just to illustrate that we can reuse this thing, so let's do console.log. Why don't we can give ourselves some little messages here to help us remember what's going on. So I'll say, I'm going to plug in a string this time. Cost is 100, tax is 10%, and then I'll do another one. Let's do a totally separate one here. I'll say cost is 200, and tax is 20%. And again, we're going to call the function again. Well, let's just do 10%. Cost with tax. This time we're going to plug in 200 for the first input and 0.10 again for the second input. But in order to see it, we need to console.log it. And now if we run the whole thing, well, this time we have 200. We're multiplying by 10% again, so we should get 220. Let's check it out. There it is. So we got a little message. Cost is 100, tax is 10%, got 110. Cost is 200, tax is 10%, got 220. So that just shows us these functions are reusable. We can keep using these over and over. Okay, so I hope that helps you understand a little bit better how this whole thing works. That you call a function, your computer is going to look around. It's going to say, where is that defined? Where is this thing called cost with tax? How do I have any idea what to do with this? Oh, there's the definition. It's right there. Now I know what to do with this. Okay, so I have an input of 100, replace that. I have an input of 0.10, replace that. Anywhere in the body of the function, this is called the body, and this part on the top is called the head. Anywhere in the body of the function, we're going to substitute in that value. Okay, so that is our idea of, that's a very, very basic function. The next one I want to do, let's make another one. Now this one, I'm going to give you let's see here. Okay. Let's do another one, but this one's going to be a little different. So what I'd like to do is I would like to, I'll do the description of it up here. Okay. What we're going to do is we're going to have two different possibilities for output now. Actually, how about we do three? So this time we're going to be using conditional statements in our function definition. Okay. So what we're going to do is we're going to have a function that takes in a number, one number, and outputs a string. This is going to be a little bit different here. So this function will give a message to the user that describes which motor vehicle they should use depending on how many wheels they want to be on. So this, again, kind of a simple function, is going to ask for how many wheels do you like to be on, and it's going to output either car or motorcycle. Okay? So I want you guys to try this, but you're going to notice something, that what happens if the user doesn't plug in 2 or 4? That's where we're going to use the if-else that I was talking about earlier. So first of all, I'd like you guys to try to make this. So we'll call this function vehicle message. And then I'll have num wheels. So if the input num wheels is 2, I want a string output that says you should get a motorcycle. And if the input num wheels is 4, I want a string output. And you could just do something like this, but instead of hello, you would put the message, the whole message. Okay, so I want you guys to try to do this. If the input is 2, output you should buy a motorcycle. If the input is 4, the output should be you should buy a car. And then we'll talk about that in-between case, right? Okay. So you guys can pause it, try to do it. Remember your whole conditional statements. If, then some condition, then some parentheses, or some curly brackets. And, okay. Go ahead and pause it and see if you can figure it out. All right. Hope you guys figured it out. If not, no worries. I'm throwing a lot at you. Now we're combining function definitions and also conditional statements. So let's make this thing. So we've got our num wheels. We've got the name of our function. If we go back over here, we have the keyword function. Got it. We have the function name, vehicle message. We have our parameters. In this case, we only have one parameter, so we don't need any commas. Then we have our steps, and we need return somewhere. Right? We need some output. So we're going to do this. If, now I'm going to indent everything that's in the body of the function to help us kind of remember what's inside of it, what each layer is on. So this if here, we're going to first check if the user entered 2 wheels. Okay, so if our num wheels is exactly 2, then we can return, you should buy a motorcycle. Okay. Else, return, you should buy a car. Now, this is the condition we're checking. It's something that's very important. If you need, I want you to, this is something I definitely want you to write down in your notes. The condition we check in here, again, don't get mixed up, because this parentheses for an if is not the same thing as parentheses for a function definition or a function call. In here, there should be a Boolean expression. Whatever's inside of here should evaluate to either true or false. That's very important. So we have a double equal sign, and it'll be true if these two things are equal, and false if these two things are not equal, right? So let's take a look at what happens if we run this thing. So if our condition is true, depending on what num wheels is, right? Depending on what value we plug in. Because later on we're going to do something like this, vehicle message, and we're going to plug in 2, or maybe we're going to plug in something else, 4, or something like that, right? So we're going to plug in some argument, some real value for num wheels, and then we're going to compare it to the literal number 2. And if they're the same thing, we're going to output this value. Else, so this is if our condition we check here is false. But you see, this doesn't match exactly what I was trying to get you guys to do. In fact, I feel kind of bad that I set you up for disaster. Because if you plug in 3, it says you should buy a car. Well, cars don't generally have 3 wheels. If you plug in, 185, it also says you should buy a car. If it's exactly 2, this would be true, right? If num wheels is 2, this will be true. It'll run this line, and because it's a return, doesn't do anything else, right? It gets to this line, vehicle message, the function stops, right? If it's not true, it does this one. Well, why don't we just test it out first and see how it goes? I should put the cases inside here. If 2 wheels, return a message about motorcycles. If 4 wheels, return a message about cars. Now, what I'd like to do is add a catch-all for any other amount of wheels. Else, return a message about you need something about not needing a car or motorcycle. Well, let's try this out. As we talked about, it'll either say you should buy a motorcycle, but all other situations it'll say you should buy a car, right? I like to think about else as if there's trapeze artists, and it's the big net at the bottom that catches all the things that fall through the other nets or something like that. So let's try running this function. Let's try calling this function. So vehicle message, and we're going to plug in here. Well, let's try 2, right? That's the case that we have accounted for right up here. And I'm going to console.log it so we can see the output. And let's run it. Okay, so we got this message. Our input was a number. Our output was character data. It was a string. And we got the message, you should buy a motorcycle. Okay, well, let's try plugging in a different value. Let's say I want a 6-wheeled vehicle. It says you should buy a car. Okay, well, Maybe there are some big rigs or some vans, some like dually trucks that might have 6 wheels. That's possible. Now, what if I have 1 wheel? It still says I should buy a car. Okay, well, that's kind of problematic. So what if we want to, let's take a moment and go back to conditional statements and not worry about the bigger function thing. What if we want to have not just 2 forks in the road? I mean, ultimately, the most simple conditional statement that we could do that's valid is something like this. If our num wheels is 2, it does this. Otherwise, if this is not true, it does nothing. That's valid. You can do that. Our next step up is to add in this else. So if this is true, do this stuff from this curly bracket to this curly bracket, right? Otherwise, if it's not true, from this curly bracket to this curly bracket. Okay, well, what if we want more than just two forks? We can add in an else if. Now, the else if, we do need to supply a condition. Remember, the catch-all net at the bottom of everything, you don't need to say else, then supply a condition. It just is understood that if any of these top ones are true, do that. Otherwise, do else. Well, let's add in an else if for if your num wheels is 4. Else if num wheels is exactly 4. Now this will have its own curly brackets. Oops. Return, I'm going to indent, return, you should buy a car. For this last one, we'll just say, I don't know how to help you. Kind of rude. That's all right. So our first condition, if num wheels is exactly 2, return this. Remember, if it gets to any of these, this block, if this is true, it does this one, and it doesn't do any of the other ones. If it passes this first one, if this is false, it goes to the second one and checks this one. Why did this one? Oh, notice it didn't highlight because I didn't capitalize that W. Now, if this one is false, but this one is true, it does this one and doesn't do any of the other ones. We could add in more else ifs also. Else if num wheels equals 6. We can add infinite else ifs, but there can only be one starting if and one else at the end of everything. And it makes sense. Again, I like to think about them like we have a bunch of nets above each other. And if the first net, if whatever we throw in there gets caught in the first net, it doesn't go to the other ones, right? It stops right there. It doesn't do any of the other ones. So if it gets through all the nets, we can set up a situation like this is what happens if it gets through all the nets. We could do this, right? I'm going to get rid of this one though. So now we're back to the original idea. If our number of wheels is 2, you should buy a motorcycle. If our number of wheels is 4, you should buy a car. All other situations, we're going to return, I don't know how to help you. And again, this whole function converts a number of wheels into a message. That's what this thing does. Our idea of functions taking in some number of inputs and producing an output remains the same. All right, well, why don't we test this out? I'm going to say I want negative 56 wheels. So we're going to call the function vehicle message. Our computer is going to look for the definition. Oh, look, there it is. There's a definition. There's vehicle message right there. And we're going to substitute in negative 56 anywhere where there's num wheels. First, it's going to check, is negative 56 the same as 2? No, that's not true, so we'll skip over this. Is negative 56 the same as 4? No, that's not true. Then we get to the else, and that's just all other situations. It should do this one. So why don't we test it out? So I plug in negative 56. I don't know how to, I want to be a little more kind of New York rude or something. I don't know how to help you, bub. All right. I can't help you, sir. You're asking me for a negative number of wheels. I don't know what to do with that. So let's try out some of the other cases that we did account for. So we have 2 still. That one should work. You should buy a motorcycle. Then we have 4. You should buy a car. And then we have some ridiculous number. I don't know how to help you. All right. So now we've got this little reusable tool. Maybe this could be part of some bigger program or some bigger function that's handling, a car purchase or a vehicle purchase, some automated, like, tell me your dream ride, and plug in your number of wheels, tell me what terrain you want to be on. This could be a part of that. Thinking about modularity, how this could be one part where we're, we're narrowing it down based off of the number of wheels. Okay, so there's that example. Now the next thing I want to talk about, we're going to kind of change gears a little bit, because you've seen how we can define a function, and we can have this little reusable tool. Then the steps inside the function, we can use all these different components like conditional statements. We're going to learn some other ones too eventually. But already, by having functions, we can start to build up these complicated things based off of these little modules, each of these functions, right? So what I'd like to do is just talk about problem solving in general. And anytime I'm confronted with a problem, I like to walk through a certain sequence of steps. Now I have to be honest here, part of these slides is based off of a different class where you might see a couple terms there that don't apply to what we've talked about so far. But I will highlight the things that I want you to really focus on. So let me pull that up. And then after that, we're going to do an example combining all the stuff we just learned about and the problem-solving flow. Okay, so say we've got a problem. We want to write a program that will allow us to solve this problem, right? And like I said before, this applies to other problems too that you're not going to write a program for, but that's the focus of this. So the really big goal here is to solve the problem outside the programming language. And in order to do that, there's a couple steps that we can do. Then we write the program. We actually write the function or series of functions or whatever. And then again, like I said before, test it out. You gotta test it out. Don't just have faith that it will work. There's always some little thing that you need to adjust. And the great thing about coding is that you can test it out on the spot, right? You don't have to do anything complicated. You can immediately just start plugging values in, getting output values, and see if it works. So I want you guys to get into the habit of following these steps, at least some version of this. If we had more time, I would actually have us do a ton of these, but unfortunately we don't have enough time for that. But I want you guys to especially take notes on this part, kind of even in your notes be thinking about, well, what would I do in this situation? What kinds of things do I do already that are just like this? So this is the idea here. This is exactly what I want you guys to do. So you're confronted with a problem. The first step is to describe your particular problem or task with enough detail to solve it. So that means, not just, calculate money owed. Like going back to the example of calculating the cost with tax. Doing something like saying, calculate groceries. Well, that's not really clear because this could be used to calculate other things, right? And what does that even mean, calculate groceries? Like there are so many different ways that could be interpreted. So to be very clear, you could do something like, calculate tax. That's also kind of ambiguous, right? Because if you're just calculating the tax, that doesn't really help us out. right? We want to be more specific. We want to calculate the cost with the tax. So anytime you're confronted with a problem, I want the very first thing to do is write down a sentence or two that actually captures exactly whatever it is, the big picture thing that you're trying to do. You don't have to do like the details. That's not important. And you'll see this is really important because later on when we're hammering out the details, you're going to get so muddled, you're going to be like, what was I trying to do again? So having this as almost like a label at the top, just to kind of remind myself, like your mantra, what am I doing? Calculating the cost of the tax. What am I doing? Creating a program that converts a number of wheels into a message so someone can figure out what kind of vehicle they want to buy or something. The next step is to brainstorm. And this is a great step because there isn't much restriction on it. Now remember, the computer does need to do things in a certain order, right? We can't start calculating the cost with tax until we figure out what the tax is, right? We have to have that value in there somewhere. But in this step, you're just throwing things down. Okay, so if I need to do, I need to have this piece, I need to have this piece. Next, you create a structured model. Sometimes you can use flowcharts. This piece leads to this piece. There are these things called hierarchy charts where, if I have to do this big step, that involves doing these sub-steps within it. And pseudocode, which is what we're probably going to focus more on than either of those two other ones. So pseudocode is going to be, it's just like programming, except you don't need to worry about the curly brackets. You don't need to worry about all of the little syntactical symbols. You just have to remember things are in the order they would be in. And you have to maybe do a little indentation so we know that if we're saying this function does these steps, we can tell what steps belong to each function. Then we work out the actual steps we would do in the pseudocode, and then finally you would write the actual program and debug it. So the parts that I want you to focus on are the first one, describing your particular problem or task, and with enough detail to solve it. This is really important because you're going to be like, first you're going to say, I know what I'm doing. I'm in the middle of doing it. I'm not going to forget it. And you get far enough in, you're going to be like, where are my feet? Like, where are my hands? And definitely the brainstorm portion. And then definitely the pseudocode and the writing the program step. So let's talk about describing the problem. So this step is fairly self-explanatory, but it's often underestimated. We need to describe it with enough detail that we can start building an idea of the solution. And again, often you'll get lost in the details when you're actually solving the problem. So to be able to refer back to like, this is what I'm doing, this is what I'm doing. Remember, it's all about juggling how much stuff you can fit in your head at the same time. This allows you to kind of take that piece and put it somewhere so you're always refreshing your memory on it so you can store other things in your head. Now this step, it might be the most important step. This is where we create informal list. That means that there's not too much structure to it. There isn't like a mandatory order. There isn't like you have to indent or anything. This step, you're just throwing things down on paper or wherever you're doing it. And I would highly suggest doing it, somewhere where you can draw charts and things, because sometimes having a visual way to solve your problem is going to be the thing that makes something click. So the order is not important, and list anything that might be relevant. You can decide that those things are not relevant later on. This is kind of like the frontier, right? We don't even know where to start. Let's just start throwing things down. Right? There are some strategies here for this. So it always helps to be thinking input, processing, output. So you could start from the beginning and just be thinking, okay, what are some pieces of information that we'll definitely need as input? Like in order to solve this problem, like I would need to know this thing, right? Another strategy is to look at the end. Once my program is done running, what is the output going to look like? Should it be positive values? Should it be negative values? Should it be decimal? Should it be strings? If you know any of the actual formulas for calculating things, like this is where you could add that in. And also the relevant formulas, right? So we'll go through an example, but this part is really important. Okay, well, we'll skip this structured model, and let's see here. So once you have the out of order informal list, we're going to start to be building a pseudocode solution where you actually do things in the right order. You don't leave out any of the steps. I want to point out something here. So look at this. This is in Java, but it applies to JavaScript also. So here I write, in order to output something on the screen, like our console.log, system.out.println hello world. Remember, the whole point of pseudocode is that we want to get rid of the specific rules of the language and just have some simplified way to describe the steps of our solution, so that we're not worried about too many different things. We're just focused on what are the steps I need to do to solve the problem. So imagine here we have console.log hello world. You can just do display hello world or something like that. Definitely, just to save space, use operators anytime that you have an operation. So instead of using the word add, why not just use a plus? And it's very, very clear. It's going to make it less kind of jumbled. And if you do use any variables if you're planning on using any variables in your actual program, in your pseudocode, actually use those variable names there. And this is important here. Don't skip any steps. So this step in terms of the entire problem-solving flow is the closest we're going to get to the actual programming solution before we actually start programming. And I like to think of this process like we start out very broad and then we narrow down. Or for some reason I had some students that really liked this one year. If you're ever sanding something, like, I don't know, probably not many of you are carpenters, but there's a process where you start out with a very rough grit, and then you use a finer grit, and then you use a finer grit. And that's basically what we're doing. We get this rough idea, and then we shape it a little bit, then we shape it a little bit, and we get more and more precise with it until we get to our actual code. And finally, the last step, where we take our pseudocode, and then we actually write out the real code based off of it, and then try to break it, which is always fun. Okay, let's take a look at an example of how to do this. So we'll start out. Here's our problem. We want to calculate the average area of two circles. So going back to, you might want to write, where was it? You might want to write this part down. Just take a second and we'll walk through these steps together in this example. You can kind of see where each of these steps are happening. Okay, so we want to calculate the average area of two circles. So how can we do this? So now we have our specific problem. We have it down pat. We know exactly what we need to do. Calculate the average area of two circles. How are we gonna do that? So first of all, what would we need to do in order to calculate the average of two things? Well, we need to have the average formula in there. We also need to be able to get the area of one circle, right? So in order to get the area of one circle, well, we need the formula for the area of a circle. So here we have and notice right there that even I was a little bit out of order compared to the notes. This step right now, the order's not important. Just make sure you're listing down all of those things that you need. So we know we're going to need the radiuses of those circles in order to calculate the average area. So there's some inputs that we need, right? Starting from the end, we should have positive numeric values. So that kind of helps us, especially later on when we're debugging. If we get some crazy values like a Boolean or a negative number, we know we did something wrong, right? But it helps us kind of build a framework. So we know we should have positive numeric values because no circle is going to have an area of 0, right? Or negative area. And then finally, relevant formulas. So we have our formula for average, which is our sum of our items divided by our number of items. And then we have our area of a circle, which is pi times r to the power of 2, pi r squared. So this might look like this. So we're going to get our radiuses. We got our formula for the average. We got our formula for the area of circle. And we need to add the circle areas, then divide the result by 2. Notice this is very informal. We're just kind of like getting the idea, and we're still very rough, right? This is an example of a hierarchy chart that some of you might find helpful. If you want, go ahead and pause it. I'm not going to spend too much time on it, but it's a visual kind of representation of our solution to the problem, where this top node here is just the overall, like, what are we trying to do? Average area of 2 circles, right? Then we break it down into these sub-steps, but they're not the most detailed steps, right? They're the kind of sub-steps. Then within each of these sub-steps, in order to do this, we need to get some input about our radius 1 and get some input about our radius 2, right? We'll actually get some input values. And you'll see that doing this allows us to see which sub-steps are parts of other steps. And this might be very useful when you have a really, really big, complicated problem. So if you want to take a second and take a look at this. Okay. Here's another example of a visual way to represent the solution to a problem, where we have a flow chart that basically, it is a linear thing where we go, well, not always, but when we start out, if we don't have any conditional statements, you just have a line and you can see exactly what happens sequentially, one step after another, all the way down to the end. You'll notice that there's some different shapes here. If you want to talk about that with me, feel free to. You can send me an email and I'll tell you what that means. Okay, here's an example of pseudocode. In case you're wondering about what it looks like, this is kind of what I'm expecting, and this is what I feel is the most helpful to you guys. So we start out particular format. We're describing what data type. We're creating some variables here. Here's another variable where, because we're going to be reusing pi so much, why don't we just store that value in this variable called pi? And notice the data type is a number. So we don't have to do this in JavaScript, right? But doing this might help us stay clear about, what are the steps. What exactly we're working with. So here, we're taking in 2 input values. We're calculating, so here I have A1, which is our area 1, and I have A2, which is our area 2, and then our average area is this. So display the average area, blah, blah, blah. Anyway, the point here is that there are no curly brackets, there's no complicated syntax. We have used a kind of condensed way of describing things where we're using operators, plus sign, slash for a divide, to make it really clear and less jumbled. And the whole point of that is to avoid ambiguity. So this is why math is so formal. It's just so we can focus on what's happening and not get lost in words and things like that. So this is what the pseudocode look like. Okay, I want to go through one more example of this. How are we doing on time? Oh, doing great on time. Okay. I want to go through one more example of this because this pretty much encapsulates... Oh, I was out of frame the whole time. That's fine. This pretty much encapsulates the whole idea of what I want you guys to get out of these lectures is this skill. To see a problem, to be able to break it down, and then to be able to also know enough of these concepts that you could implement them in some programming. Conditional statements, functions, things like that. So let's do a little bit more complicated of an example, and one where we're actually going to need to use some of this planning and problem solving, because up until now, these have been pretty trivial, right? So let's do something that's a little bit bigger and see how we can apply these steps. I'm going to go back to this one and see how can we apply these steps in order to solve this problem. So I'm going to delete this. Okay. So, actually, I'm going to go back over here. Typically, what I like to see in my students' work is some description and some planning above each function definition, where you describe to me what does it do, what are the inputs and outputs, and what are the steps taken. And this is if it's complicated. If it is non-trivial. So let's go through this example really quick. I want to calculate, so step one is going to be to describe your particular problem or task. So calculate average pay for 3 employees, taking in a pay rate and number of hours worked. And then some extra details. If the amount of hours is over 40, those hours are, in those hours, pay rate is doubled. Okay. Wow. So we want to calculate the average pay for 3 employees, taking in a pay rate and number of hours worked, let's say for each. Oops. For each of them. If the amount of hours is over 40, in those hours, the pay rate is doubled. Okay. So this is our task. Oh boy. Okay, so 1, describe task/problem. There it is. And so anytime I give you guys one of these problems, sometimes you're just going to basically repeat whatever I asked you to do. That's fine. But I want to have it there written down somewhere so you can refer back to it. So this is our goal. Average pay for 3 employees, taking pay rate, number of hours worked for each of them. If the number of hours is over 40, the pay rate is doubled. Okay. Our next step, after describing the problem, if we go back over here, our next step is to brainstorm. We're going to create an unordered list of information that might be relevant. So first of all, what are some things that we can do that are relevant? And let's go back over here. If we started from the beginning, what are some pieces of information we'll definitely need as input? Well, for input, well, in order to do this calculation, we're definitely going to have to calculate the pay for each of our employees separately. So pay for a single employee. And that means, I'll even do this in a sub level for this one. That means I need a pay rate. So I'll say input, pay rate, and num hours. Okay. So that's what we're going to need in order to calculate the pay rate for a single employee. Then in order to calculate the average of 3, sum divided by 3, sum of total pay I'll just indent that. I'll put some dashes here this is indented because it belongs to calculate pay for a single employee. And then input pay rate and number of hours. Well, also, if we want to calculate the pay we'll call it the total pay for a single employee. Total pay, be another one. Total pay equals pay rate times hours worked. But maybe we'll put a parentheses here about don't forget overtime. That's actually very vague. Pay rate times 2 if hours worked is greater than 40. Okay. And so let's see here. Going back to our informal list. So we're going to start from the beginning with some pieces of information. So we definitely need a pay rate for each employee, and we need a number of hours worked, right? If we look at it from the end, well, what is going to be the outcome of this entire thing? It's going to be a number. It's going to be a number. It's going to be a positive number, I hope. I mean, it should be, because everyone is generating some income, so it should be a positive number. I think that's pretty much it. We don't know any of the characteristics of the pay or the pay rate. We could be dealing with like a big buck CEO who makes like ridiculous money. We could be dealing with someone who doesn't make that much money. So that we don't know exactly the range of values. We do know it's going to be positive, and we do know it's going to be numeric. So that's something that we should be thinking about. So let's put that down so we don't forget about it. Okay. So our output value will be positive numeric. Here I'll say start from beginning. No, actually, I'm sorry. This is our informal list of relevant information. And the different things that may or may not be important. This JS Fiddle is kind of indenting things for me in a strange way. I want this to line up with that one there. Okay, that's all right. Okay, so we talked about what we need as input, and we could be thinking about what's the output going to look like. And then we also have some relevant formulas. So again, average is going to be sum divided by num items, and our pay rate is well, I already wrote it. Put it over here. Total pay. Well, that's already up there, so I'm glad we have it listed at least somewhere. The order is not important again. Now, already I'm thinking this. We can start to break this into different pieces. We can have different functions that do parts of this problem, so we don't have to worry about the overall problem. Right? So this is the first time that we're actually using some modularity. I'm really excited about it. So let's see here. We could have a function that calculates the average of 3 input values. We could have a function that calculates the pay for a single employee and use those things together. And we could also have a function that does all of these steps combined. So maybe down here, we could say our functions, list of useful or functions that we're going to make. 1, calc single employee pay. 2, average 3. Now it doesn't matter as long as they're numbers. We don't know what we're getting the average of 3 for. We could reuse this function, calculate the average 3, numbers of bananas people eat in a day or something like that, right? This is a reusable little function that we made. So I'll just say the average 3 numbers, and finally, our overall calc average pay of 3 employees. Okay, awesome. So we have our task. In case we get, like, what am I doing? Can refer up here. We have this. Let's see here. I'm going to clean this up a little bit so it's easier to read. Let's just put this on another line. That's fine. Okay, you get the idea. So we have an idea of how we're going to implement these things. So we have an idea also of each of the different pieces that we can use, so we don't have to do everything at the same time. So let's see here. Well, we can start with this one because it's really easy. So let's define a function that calculates the average of 3 numbers. It doesn't matter, what we plug in. So we'll start with the head of the definition of the function, and we start with the keyword function. This function, well, we'll give it a name, average of 3. Now, I don't know what these values are going to represent. We should always be very descriptive. In this case, because it's general, I'll just say num1, num2, num3. So that's going to be our argument names. Okay. Oh, and by the way, if you guys want, and I highly suggest you do this, try to do this. Try to do this without me. And then you can come back to this if you need a hand with anything. And your solution might be a little different than mine. That's fine. For now, we're not worried too much about efficiency. When you guys get a little further along, we're going to be doing analysis of your algorithms and figure out how efficient they are for time, how efficient they are for space they use, storage, things like that. But for now, let's just get the job done. And then we can practice getting the job done, then we can really hone our skills. Okay, so we're going to have 3 numbers, and we need to calculate the average of them. Well, the average is just our sum divided by 3. So I want to do something. We could do something like this, right? Let sum, let's call it, I'm scared that sum might already exist. The word sum might stand for something in JavaScript already. So I'm going to call it this sum. Kind of a messy trick, but it works. This sum equals num1 plus num2 plus num3. And then I want to output the sum divided by 3. Return this sum divided by 3. So this little function should do the trick. Now, I want to point something out. We didn't really need to store this. I'm going to keep it here as a comment. Now, when I put 2 front slashes in front of this line, your program ignores them. So it's your way to keep some code in there without actually running it. That's also how I did this giant thing, the front slash asterisk, and then asterisk front slash. This is called a block comment, where we're commenting a whole chunk of code here. This is a fantastic way for you to leave notes to yourself, or if you've got a big complicated problem big complicated function or program, and some part of it is breaking, you can use a process of elimination by commenting out chunks of it until you figure out which part of it is breaking it. It's a very useful thing, but we'll talk about that later. So instead of doing this, first creating a variable, storing the sum, why don't we just do it all in one go? So I'm going to return num1, num1 plus num2 plus num3. And notice the parentheses are very important, otherwise we would divide num3 by 3, right? So we're going to output, that's what return means, we're going to output this expression here. All right, we have our first function. Before we do anything, before we move on, let's test it out. Let's do a really, really simple example. Let's see. So we'll do 3, 4, 5. So we'll do average of 3. Plug in 3, 4, 5. So let's see. 3 plus 4 is 7, plus 5 is 12, divided by 3 should be 4. I mean, you know, we're 1 away from mean the entire time. So let's do console.log. This should give us 4, right? So let's test it out, make sure it works. Create a test case that you could do in your head so you can verify that your function is working properly. And we should have an output. If I run this, should have 4. Okay, great. So that's one of our working pieces so far. That's not where we're going to use average of 3. But now we have the definition of it. We can reuse it somewhere else, right? Okay, next step. Well, we need to calculate the single employee's pay. Okay. Now, I forgot to do this, where I did want a comment above each of the functions. And we'll call this one, so, average of 3, all-purpose function to calculate the average of 3, the numeric average, 3, the mean, we'll say the mean of 3 numeric inputs. And now an example of describing how it does it, you know, we could say add all inputs, divide by 3. But this is pretty trivial. In the case where we start getting more complicated, I definitely want you guys to include something like that. Okay, so let's take a look. Let's start with our next function. So I'm going to make a little comment here, and this one is, we'll call it calc employee pay. Okay? And first I'm going to describe, purpose. Calc employee pay, purpose. So this one, in the purpose, I like to actually describe the inputs and outputs. So we'll say this function takes in a pay rate and a number of hours worked by an employee, and returns that the product of 2. If the employee worked over 40 hours, any amount over 40 would be multiplied by 2 times the pay rate. Okay, so that reminds us, what are we doing here, right? We might do something like this, inputs, just to make it very clear. Pay rate, number pay rate, number hours worked. And yeah, that's fine. Now we'll do output. Now, that's fine. Okay. This is pretty trivial again, but if we get really complicated, I definitely want you guys to start describing how you did it. Not just what it is, but how you did it. All right. So we're going to define another function that does this. So function calc employee pay. We have some parentheses. We're going to have 2 inputs for this one, right? So number, pay rate, oops, just pay rate, and hours worked. Okay, well, we've got a little extra detail in this one, and we could even break this one down further. Why don't we solve the base problem first, assuming that they don't make anything above 40. So it would be pretty simple. We would just return pay rate times hours worked, right? Now, what happens if it's not the case that our hours worked was under 40. Well, this kind of branch that we have reminds me of something that we could use. Because in one case, we're going to use this formula, this particular formula, but in another case, we might use a modified formula. Well, what could we use when we want to branch our problem out? And we might want to run this code in this situation, we might want to run this code in a different situation. You guys probably remember our conditional statements, right? We'll have an if. If our hours worked is, well, let's say less than 40, now this one's easy. Return pay rate times hours worked. Makes sense, right? Okay, now, otherwise, so if our numbers worked, we'll say, how about less than or equal to 40? Because if it's exactly 40, it's not overtime. So if it's less than or equal to 40, return pay rate times hours worked. Else, this one only has two forks. Either you worked overtime or you didn't work overtime. So we don't have to do any else if, luckily. In this case, we're going to return 40 times pay rate. That's their normal pay, right? So that's the portion of it that was earned at the normal pay rate. Plus hours worked minus 40. Here we could do some. We want to be really cautious. We can get some extra parentheses in there. So we want the amount of hours worked over 40. That would be hours worked minus 40, right? That will tell us exactly how many hours we worked beyond 40 times pay rate times 2. And I'm going to put some parentheses around this entire thing. Okay. And let's do a little sanity check to see if the right things are happening at the right times. So ultimately in terms of our order of operations, things in our parentheses are going to happen first. In fact, if we have parentheses within parentheses, those things will happen even before just having one set of parentheses. So the first things that are going to happen are going to be in here. Now, our parentheses, I feel very confident about this, are left associated. So because we have two sets of parentheses on the inside, we would do the left one first. So hours worked minus 40. So this would give us our hours beyond 40, be multiplied by pay rate times 2. So this would be calculated separately, although this part doesn't, well, yeah. So that would give us our pay rate times 2. So this would be our number of hours worked beyond it. Now I'm concerned about giving the employee too much money, because it feels like we got a lot of numbers here. But this would do the case for calculating how much they earned in overtime money. And then this side here, well, it's always going to be it's going to be 40, right? They've gotten beyond 40. So let's give them their 40 hours at their regular pay rate, and plus this other stuff. All right, awesome. Let's see if we can come up with a very simple case. Oh boy, I hope I can do this. That is something that we could just do in our heads. So let's say I worked 41 hours and my pay rate is $1 an hour. So just to make it really, really easy, right? So if I worked 41 hours, then 40 of those hours would be my regular pay rate. So it'd just be 40 times 1. That 1 hour beyond 40 should be adding 2, right? 2 times 1. So our total should be 42. Let's test this out. So I'm going to call the function, but of course I have to console.log it. We'll do calc employee pay, and our pay rate, well, we're going to make it $1 an hour, and then our hours worked is going to be exactly 41 hours. And notice that we have to match up, our arguments are going to match up based off the order they're in, separated by commas. So that first one should be our pay rate. There's our $1 per hour. And our hours worked will be the second one. So if everything worked out okay, we should get the output 42. And if it doesn't, then it'll be a nice little mini lesson on debugging. So let's see here. All right, there it is. So we got 42. All right, makes sense. Let's try a different case. Let's see what happens if I did less than 40. We should get just 1 times whatever number of hours I work. So I should get 23 here. Awesome. So it makes sense. So this one works just fine. Okay, we're so deep in. What are we trying to do? Why are we doing this? Oh, yes. Okay, so we can go back up to this. What's the overall task we're trying to do? Oh, I'm glad this is here. Some of you guys are probably rolling your eyes right now like, yeah, I remember, but you guys, when this gets really complicated, you're going to be very thankful for this. Okay, so going back to our functions that we're making, our whole problem is we need to calculate the average pay for 3 employees. So we have a way to calculate the pay for 1 employee. We have a way to calculate the average of 3. Now we need our big honkin' wrapper function that is going to just take in our input information and do all the work for us. It's going to spit out 1 average. So let's start out with our little comment. So this one will be calc average pay of 3 employees. Purpose is to calculate the average pay of 3 employees based on the numbers of hours worked and pay rate for each employee. Okay, that looks good. And then our inputs. All right, well, our inputs are going to be a little different here. Purpose. Inputs. So we need a pay rate and a number of hours worked for each of our employees. So why don't we do this? Keep a consistent numbering system so we can keep track of what belongs to what. And we can do this. So let's say I'll call it PR for pay rate, PR1, hour 1, PR2, hour 2, PR3, hour 3. We're going to need to plug in all these values. There's no way we could calculate this without these values. So this function actually takes in 6 inputs and boils down, it makes 1 output, which is the average of those. Okay. And let's see here. Maybe we could do a little pseudocode. Let's just go for it. Okay. So we're going to define our function. Function calc average pay of 3 employees. And here's where we're describing these placeholders, right, for our inputs. PR1, HR1, PR2, HR2, PR3, HR3. Okay, that's a lot of inputs. I'm glad we have a function. Once we create this function, we don't have to worry about this again. We can calculate. We can grab any set of 3 employees and find out what's the average pay of them, so they can fight each other about why they're getting paid less than their buddies. Or they can see that their pay is way lower than the average, or something like that. Okay, so we have our keyword function. We have the name of our function. We have our parentheses, and then our parameter names. Then we need the steps of our function. Once again, going back to this. So we have keyword function, function name, parameter name separated by commas, our steps, and finally, somewhere in there, at least 1 return. And notice here, in this function, there's actually 2 of them, kind of like the other example we did. But as soon as our function sees 1 of those, it spits out a value, and that's just it. Okay. So how are we going to do this? So first we need to calculate the pay for each single employee. Now, let's do it in this expanded form first, and then I'm going to talk about how we could condense our code more. There's really a big debate about whether it's good to do like this very condensed version or to be more verbose and kind of spell out each of the steps. Some people, they see the condensed form, they're like, oh, that's so clever, that's so smart. I've heard a lot of employees actually, though, when you're working in a big team, it doesn't hurt to be really clear about what each of the pieces are, and it'll be much easier to be able to collaborate with other people. There's a lot that goes into deciding about whether or not to do that. Like, especially if you are doing a lot of extra steps that are actually slowing down the whole thing, then maybe you don't want to do the more verbose form. But if it doesn't matter, having these extra steps, then sometimes it doesn't hurt. But why don't we do the expanded form first? Then we can talk about how we can make it kind of more condensed. But ultimately, I think it's going to be probably the same amount of steps with a tiny little bit less storage. So let's start out. We're going to calculate the pay of one employee. So we'll say E1 pay, or if that sounds like we're going to get. Let's do this. Well, no. I might want to change this to actually call it pay 1. Because imagine there's other things that we've called like PQ or have to start with P and we can't remember which one's which. It might help to actually call this pay 1, this one hour 1, or hours worked 1 or something like that. I just want you guys to have this instinct where if you feel like you're getting mixed up on your variable names, to start to be more verbose about them. And like that's another one of those things that'll save you a lot of suffering. If you start to feel like, oh my gosh, I'm getting a little confused, take a step back, rename things so it's much more clear. Okay, so we'll call it E1 pay equals. So we need to calculate the pay rate of the first employee. Well, we have a tool that does that. We have a function defined that actually does that for us, and we can use the other functions that we've defined in the body of other functions that we define. It's totally valid. So I'm going to do calc. What's the name of it? Calc employee pay. Now, if we use the function calc employee pay, how many inputs does it need? So it looks like it needs 2 inputs, the pay rate and the hours worked. So I'm going to put in PR1 and HR1. Now, this is pretty wonky. In fact, what I'd like to do is I'd like to do a little function call. Imagine that we finished making it. It would look like this. Calc average pay of 3 employees. And inside here, we would have, okay, pay rate is 10, rate is 10, pay rate is 20, work is 10, pay rate is 7, and hours worked is like 45. This is what's going to look like when we actually use this function. When we actually call it, it's going to look like something like this, okay? So just keep that in mind. So we're going to pass in 10 in PR1. We're going to use that 10 and plug it in to calc employee pay. Calc employee pay is going to run. It's going to use that 10 in pay rate. If that makes sense, you could think of it like a cascade. But at any one moment, we're only in one place at a time, right? So we're running calc employee pay. We're running calc average pay of 3 employees. And one of the steps is to run calc employee pay. So now we're in calc employee pay until we get to a return. When we return, we kick back out here, and whatever this outputs, we're going to store in E1 pay. And we're going to do this 3 times. So I'm just going to copy and paste. So E2 pay, E3 pay, and this one is going to be pay rate 2, hours worked 2, pay rate 3, hours worked 3. Okay. So now we have the pay of 3 of our employees, but the overall goal is to get the average of it. We'll say let average pay of 3 equal, well, we have a tool for calculating the average of any 3 numeric values. So we're going to use our, where is it? Average of 3. And so we're going to do average of 3. And we can plug in E1 pay, which we stored the result of calculating the first employee, E2 paid, E3 pay. E1 pay, 2, employee 2 pay, and employee 3 pay. And then finally, if we're thinking about the process of defining a function, and like all the pieces that are in there, let's go back to, we're forgetting something. We need some output. We need to return something. So our goal is done, and we just need to return average pay of 3. And that's it. That should do the trick. Okay. Shall we try this out really quick? Let's see if we get any errors. So I'm going to console.log. Now I want to run this entire thing. And within the body of calc average pay of 3 employees, we're actually using 2 other functions that we defined, calc employee pay and average of 3. But look at how little work we did calculating each of the employee pays. We had a tool to just do it multiple times. All right, let's try this out. Does that make sense? 10 times 10 would be 100. 20 times 10 would be 200, because both of these would be under the 40-hour limit, right? And then this one, so let's see here, we have 400. Well, let's use our really easy example. Let's say your pay rate is 1. That's the first one. And then we'll say your hours worked is 41. So we'll have 100 plus 200 plus 42. 100 plus 200 plus 42 would be 342. Divided by 3 should be 118, 119, something like that. So let's try this out. Okay, that's pretty close. Makes sense. 100, 200 plus 42, 342. Yes, that makes sense. All right. So it works. Anyway, that was a very, very drawn out example. But this is a live example. This is like exactly how we could take something starting out with this and break it into smaller pieces. We could define functions for each of the jobs that we need to take care of, especially if they're jobs we need to repeat multiple times. And then each of our functions can be used in other functions. This was a really jam-packed lecture, but I kind of like to do this thing where I shock you guys with the overall thing, so you have it, and you have something like you could be working towards. Some of you guys might be like, yeah, I'm bored. Some of you guys might be a little overwhelmed. That's great. Both of those are great. The bored students, I want you to challenge yourself to add more features to this or to help out your buddies. But this is a good starting point for us. And we're going to just basically keep doing this for the rest of the time that we're doing these lectures. This right here that we did is what we do. So I'm glad that we have, finally, we've been talking about stuff for a while. We have a working example of, this is the kind of thing that we're going to be doing over and over and over. Solving different kinds of problems, too. I want to talk about one more thing. And then and then we'll be done with today's lecture. So I want to talk about something called the program stack. And I'm going to need to draw some pictures of this. And it actually relies on this example here. So I want to go back to that idea that whatever the computer is processing, it's just one point, right? It's just one place at any moment. So let's do this and do. What am I going to discard? Okay. So our program is only going to be, our processor is only going to be working on one thing at a time. It might be switching between them very rapidly, way more quickly than you or I could probably do. Maybe some of you guys can do it. But how does it keep track of what it's on? Where is it at any moment? And I want to get to this thing called a stack. So we learned about variables and how we can store some piece of information. It could be some value, right? Some numeric value or character value or Boolean value, but there's a storage. When you get a little further along, you're going to learn about something called a data structure. And basically there are these, we call them like kind of like containers, but that's misleading. We just have more complicated ways of storing information besides just a single storage. We have more complicated ones. We're going to learn very soon. So we have something like this. So var, we'll use let. Let age equals 15. So it's almost like we stored the value 15 in like a box, right? We have more complicated ways of storing values. Like, what if I want to store a lot of ages? Well, we're going to talk about this next time. There's a structure you can visualize like this, called an array, that has multiple slots. And each one has what's called an index. That would be these numbers here to refer to the different slots inside there. So I might do something like let ages equal 7, 5, 12, 49, 108. Don't worry about the syntax here, how we have these square brackets. 1, 2, 3, 4, 5. So then there's 7, there's 5, there's 17, there's 49, there is 108, and we don't need that fifth one. So we have different ways of storing information beyond just having a variable that just stands for one value. In this case, ages is still a variable, but what it's holding is a more complicated structure like this that has multiple slots. We can store multiple values in it. I want to talk about, or we're going to talk about that a lot. This next little bit here is more conceptual. I want you to have some feeling for what's going on when we have multiple function calls, like functions that are calling functions as their steps. The structure this is based on is called a stack. And it's kind of similar to that last one. We have multiple slots, right? But the idea is we can only access the top. We can only add to the top and pull off the top. And the example that I've heard, if you've seen one of these, it's a perfect analogy. If you haven't seen one of these, it's not going to work for you. But if you've ever been to a buffet, here's my drawing of a buffet table. Once again, terrible 3D drawing. If you've ever been to a buffet and they have like this push down plate dispenser, and there's multiple plates in here, but you can only grab off the very top of it, and you can also put them in, but you can only put them in from the top. You can't put them in from the bottom. The idea is the same with this structure for storing information called a stack, where we can always apply to the top of it, and we can always remove from the top of it. And so This structure is called, let's see here. First in, the first one that's in, right? That would be this one. First in, last out. The first one that's in is going to be the last one that eventually leaves it. And you're going to learn about a different structure that is first in, first out. That's different. But this structure, the first one that's in, that would be this one right here, right? That's the first one we put in, is going to be the last one that ever leaves this thing. Okay, so again, we can add to the top, we can take from the top, we can't take from the middle or anything like that. So let's go to this idea of, let's go back to our program and how we have at the beginning. So the way that your computer keeps track of what it's on and all of the local variables is in a stack of all of your function calls. Your function, it's like a stack of function calls. So let's say, going back over here, we have all of this stuff, and we've defined all of these functions, and then here is the first time we've actually done any action. Right here is actually where the program starts running, right here. All this other stuff is just defining stuff, right? This is actually saying do something. So if we run calc average pay of 3 employees, the first step is to create a local variable called E1 pay and then run calc employee pay. Notice that. Oh, I wish I did something a little different. Okay, I'm going to do this. Let's add in a little alert function call in here. And we'll just say, hello. Okay. So I'm doing this because I want a function call inside of a function call inside of a function call. So if we think about our stack, here's our stack. The first thing we add in is calc employee pay. That's the first function call, right? Now, our function hasn't ended yet. We haven't returned yet. So we're going through the steps of calc. Nope, not this one. Take a step back. I'm sorry, guys. Let's take a step back. I want to make this really legible, too. I don't have my normal setup, so it's kind of hard for me to write on this thing. All right, maybe you're going to have to look up my nose for a second while I write here. But our first function that we call is calc average pay of 3 employees. Okay, so let's go back over here. So I'll just call this one calc average pay of 3, I'll just say emps. Okay, so there's calc average pay of 3 employees. Now, that function hasn't ended. We're still in the middle of running it. And then we get to that line, on line 69 there, we run the function calc employee pay using PR1 and HR1 as arguments. Okay, now we add on top of the stack, what was it? It was calc employee pay. Calc employee pay. Okay, that's where our processor is at right now. Okay, so let's take a look at calc employee pay. And we're doing calc employee pay. The first step is another function call. Now this one we didn't define. This comes as part of JavaScript. But it's another thing we're doing. So here we're going to add in alert. Okay, alert does whatever it has to do, right? And then it stops running. And when it stops running, we can remove it from the stack. We take off the top of the stack, and then we're back in calc employee pay. We finish with line 45 there, and then we do the if, all this stuff, and at some point we're going to return either on line 48 or on line 52 we're going to return, right? And that means this time that we call calc employee pay, we're actually done. And we kick out, we return, we output some value. So calc employee pay, this first time we did 10 times 10, is going to output 100, and that's what's going to be stored on line 69. Calc employee pay is going to be done. So This finishes. We return a value. Now we're still running calc average of 3. Excuse me. Calc average of 3 employees. So we finished line 69, right? So we go down, there's line 70, and on line 70, we're running calc employee pay again. So if we look at the program stack, the function stack, so we do calc employee pay again, and we go through all the steps of calc employee pay. Well, that first line is an alert, so we run the alert, then the alert stops running. We can get rid of that. We return some value. That calc employee pay is done. Then we're back in calc average of 3 employees. And you can kind of see where this is going. Eventually, we get to average of 3. We run through it one more time with calc employee pay on line 71. And we have to add an alert because the first step of calc employee pay is alert. And then we get out of calc employee pay, and then we do average of 3, average of 3, then average of 3 runs, and it outputs some value. At some point it returns. It's only one step, so it just returns. And finally, so average of 3 is done. Calc average of 3 employees gets to this return, and this is done. And finally, our process is done. So this idea of the program stack is really, it really helped me understand what was going on when we have function calls on top of function calls. The first function that happens is not forgotten. It's kept in there. It's at the bottom of the stack. And all of the relevant pieces of information, like all of the variables and all that stuff, it's in there. It's still there. It's waiting for whatever's above it to stop running. But it's still in there. And maybe we have to run another one. Maybe we have to run another one. In fact, your computer is running Windows stuff on top of other stuff, on top of other stuff. And as it finishes running any of those, then they're popped off the top of the stack. And the next function resumes. So that's kind of this idea of why this keyword. So look at line 73 there, why it's return. Because when calc employee pay finishes running, it's going to return something. That means return back to what called me. When you see return, it means return back to whatever called me. So that means, okay, I'm done here. I return back to calc average pay of 3 employees. That's why that word is return. Okay, so I think that that's enough for today. We covered a lot of stuff. We kind of went over the structure of functions, about how we have the header, which has the keyword function, the name of the function, our placeholders for our inputs, also known as parameters, then our steps, and then that keyword return, which means output. Remember that idea. Functions are some number of inputs, do some work, produce some output. Then we went through our problem-solving flow. You need to describe your problem with enough detail to solve it. Then there's a brainstorming phase where you might have things out of order. You might have things that are not relevant that you might end up leaving out later. And some strategies for tackling that include thinking about what needs to be input, what kinds of pieces of information do we need to even start doing this, thinking about what form is my output going to be in, and then also thinking what are some relevant formulas that you might have in there. And then we did a couple examples of some functions, just defining our own functions. And finally, we built up to this big idea of combining multiple functions, having some big problem, and combining multiple functions to handle each of the separate parts. Some good habits like making some notes above each of your functions to help us remember, what are the inputs, what are the outputs, what is the purpose of each of these things. And at the very end, we talked about the program stack. We talked about the function stack and how the computer keeps track of all of the function calls that maybe call other functions. This is going to be important for what we talk about next session, which includes recursion, which is when a function actually calls itself as one of the steps. You can imagine that might lead to an infinite loop, and that's indeed what happens unless we account for that. So anyway, I hope you learned a lot, and I'll see you for our next lecture.